All right, so the really confusing thing, number one, was magnetic field B or H. We'll be using B. The other really confusing thing, the Earth is a magnet. Where's the North Pole of the Earth's magnet? Is that a point up?
It's not 100% up, but yeah.
Oh, okay.
It's
So that way.
no.
Is that? Silas Creek runs east-west, doesn't it? And more on the south side?
Yeah.
Yeah, so that would be what we call north.
Yes.
Okay. Everyone good with what Laura said?
Hey, you said that part.
Well, you pointed that way. I was trying to interpret. All right, so here is the confusing thing there. When you are in everyday life and you refer to the Earth's magnetic North Pole, and indeed it's near what we call the North Pole. No problem with that. However, if I take a magnet and I got a north side and a south side of a magnet and it's light enough and it can easily move, if I take, so Earth, I take a magnet, draw a little arrow, got a north and a south pole to it, which way will that rotate? If you have a compass, which way does the north end of the compass point?
Towards
Towards,
the North Pole.
yeah. It'll point this way, that's the north and the south pole. However, are north magnetic poles attracted to other north magnetic poles? So in reality, we call this the North Pole. Matter of fact, there's a reference to the magnetic North Pole, but in reality, it's actually a south magnetic pole up here. Assuming that this is what we call the North Pole and South Pole. So geographically, that's the North Pole, that's the South Pole. From a physics point of view, really, this is a magnetic South Pole, that's a magnetic North Pole.
So we've been lied to our entire childhoods.
About many things, yes.
Excellent.
So I will still make reference, if I make a reference to North Pole, and if in doubt, ask. If I make a reference to the North Pole, you should ask, is this the geographic one, or the geographic magnetic one, or the actual physics one? Now the other question. Do you have any questions before I ask my fundamental question? What creates a magnetic field? Hint, it relates to what we had just been doing for the past month.
Battery?
You said battery? More general than that. Yes, I can create a magnetic field with a battery, and a wire. Why do I need the wire? What can I do with a battery and a wire?
All kinds of things.
The simplest thing. What's the simplest thing that you can, besides just having it sit there? What's the simplest, if I take a battery and I take a wire and I connect it, what happens?
Current?
And what is current?
Charge flow.
Okay, so what creates a magnetic field?
Charge flow.
All I need to do is have a charge that moves. So I know what you're thinking. You're going, hey, that's great. Well, if I just take a charge and move it, so if I take a battery and I throw it across the room, do I create a magnetic field? No, not much of one. Especially since batteries overall are neutral. You have just as much positive as negative, so
they cancel each other out. But surely there's an equation that is going to tell us something here, or at least the relationship. So the actual how magnetic fields are created from a moving charge, we'll get to that. It actually is a calculus-based equation, so we'll hand wave some stuff. However, I do want to talk about the relationship between moving charges and magnetic fields. So I guess I did a poor segue there. But I do want to at least connect charges and magnetic field. So if I have a charge here, if it moves, it creates a magnetic field. So let us pretend that that's a charge. And I'm looking at it, it's not moving. I got the Earth's magnetic field going past it. So, putting that in the wrong place. All right, hold that thought, we'll come back to it. All right, so I have a charge that moves. It creates a magnetic field. Now, in order to figure out the direction that the magnetic field is, well, the old hitchhiker's thumb. Right-handed, don't do left-handed. It's a right-handed rule, or right-hand rule. You put your thumb in the direction that the charge is moving. The magnetic field that is created is sort of defined by the remaining fingers. So if my charge is going that way, the magnetic field is going out on top, going in on the bottom. So my magnetic field is coming out on top, in on the bottom, below it. In front of it, it's going down, behind it, it's going up. But it wraps around. So if I have a charge that is moving that way, the magnetic field, put my thumb in the direction of the charge, positive charge movement, fingers curl in the direction of the magnetic field. So it creates a magnetic field that is going around like this. So charge moves, positive charge moves. Magnetic field is created. Thumb in direction of movement, direction of positive charge flow, right thumb, charge, direction of positive charge movement, remaining four fingers, curl in direction of magnetic field. One of many right-hand rules. Anyone in here left-handed? Okay. I have some people who will, left-handed people are so used to using the left hand, obviously, that sometimes they'll just do dominant hand rule, and it's not. It's right hand. Anyone need me to actually read what I wrote?
So is this only with positive charges then?
Yeah, and negative charge would be opposite.
Okay.
So if I have an electron moving to the right, an electron moving to the right is the same as a positive charge moving to the left. So I put my thumb in the opposite direction, and the magnetic field would be into the board here, out of the board here. And if you're forgetting the notation for the 3 dimensions, that if you imagine an arrow pointing at you, you see the point. If it's going away from you, you see the feathers. So the point coming at you, the feathers going away from you. I have a marker here, let's assume it is a charge. It is at rest relative to me. Ignore what I said earlier about the Earth's magnetic field. So we have a charge sitting right there, and I have a detector trying to detect the magnetic field created by it. If that charge is at rest relative to me, am I going to detect a magnetic field coming from it? Based on what we have here.
Can you resay it?
All right, so what is the requirement to create a magnetic field?
Charge flow or movement of charge?
Yeah, okay. So if the purple marker over there is a charge, and I'm trying to detect the magnetic field coming from it, will I detect anything if it's sitting right there and I'm standing right here? All right, so Abby's going for no. Or Ryan, Manal, what do you got? So none of you say that I would detect a magnetic field. Is that you're judging from the way I asked that question, that everyone's wrong? Okay, Ryan's going with that. Is the charge moving? Well, I'm trying to detect the magnetic field coming from it. Is the charge moving? So if the charge isn't moving, will a magnetic field be created by it? No, all of you were correct before. I'm not getting a magnetic field from it. Now I walk towards it. Will I detect a magnetic field? Isn't the charge moving?
You're moving.
Am I?
You said you walked towards it.
I did indeed. Maybe I lied. What is movement? How do you know if something's moving or not? How fast are you moving right now? So a question I asked near the beginning of 151. How fast are you moving right now? Okay. How? I'm not worried about, small little movements. Why do you say you're not moving? Anyone have a different answer for how fast you're going?
Didn't you say something about like how the Earth is like moving really quickly and that like we could use it to argue a speed once they get or that I've just been hallucinating.
Wow, faded as you went. Say it again.
I remember like at the beginning of like 151, you said something about like how the Earth was like moving really quickly and that like we could like argue that like we were always breaking like the speed limit if we ever got like caught speeding because of how quickly we were. No, but that's displacement. Never mind.
No, you're on the road. It is a valid concept. When you get a speeding ticket for how fast you're going, what do they assume? Presumably the same thing that Laura assumed.
That you were moving too fast?
Relative to what?
The road?
Yeah, or the ground in general. Or are we going incredibly fast because we're on the Earth and the Earth is spinning? Actually, the Earth's going then around the sun, and the sun's going around the center of the Milky Way, and the Milky Way is moving outwards. There's lots of movement there. So when you're talking about how fast an object moves, whether it moves or not, it depends upon the observer. So, looking at that as not moving at all and I'm moving is a perfectly valid way of looking at it. And if we all had our, again, assuming that's a charge, we all had our magnetic field detectors, We've managed to eliminate the Earth's magnetic field because we are that special. You would look at that, you would not detect any magnetic field coming from that charge because it is at rest relative to you. But it is not at rest relative to me. So I would actually detect a magnetic field. There's definitely a relationship there between, well, what it's giving off and what I'm detecting. So, and how I'm moving, how it moves relative to me. That was a sentence that started out well, I think, and just somewhere crashed into a pylon. To me, that just blows my mind. The fact that it has a magnetic field or not, depending upon if you're moving. Now, in most problems, we're not worried about that. In most problems, I mean, that would be probably a quick multiple choice. Do you remember? But for most problems, I'll give you how fast it's going. It's assumed to be relative to the observer, the lab frame. All right, so we talked about creating a magnetic field, and the formula we'll get to later. The other thing is that if I have a charge going through a magnetic field, it is affected. So we have moving charge creates magnetic field. And a magnetic field exerts a force on a moving charge. So, does that mean if I take an electron and it's moving along, it creates a magnetic field? So I'm standing here by my side, the electron zipping by. It creates a magnetic field. Will that magnetic field affect it? The magnetic field that I see that the electron is creating, will the electron be affected by the magnetic field it creates? What?
You're talking about the electron creating the magnetic field and that the electron itself is going to be affected by the magnetic field, right? That's what
Yes. The magnetic field it created.
Because the magnetic field itself can, this is how I'm imagining it, like interact with other things, which could cause it to, I don't know. This, I don't know how to explain what I'm thinking.
So you're saying that the magnetic field will induce something, will, through some sort of chain reaction, create another magnetic field that affects the electron?
Possibly. Like if the electron is moving towards the marker, for example, isn't that like the same thing as you moving towards the marker, where the electron is observing the marker and therefore it has a magnetic field because it is moving even though the electron's moving towards it, so they both have a magnetic field?
But so the electron, so we got our electrons heading towards that marker right there. It says, oh, that's moving, that's creating a magnetic field. But we're standing here looking at it and going, wow, it's creating a magnetic field. That's not. So the magnetic field that this creates, because we're all standing here watching this thing go by, magnetic field it creates, is it going to affect will this electron be affected by its own personal, not its magnetic field, but its magnetic field?
I guess
Is that a guess so or guess not?
Guess
How fast is the electron going relative to itself? Yeah.
It's not,
Right.
because it's only going based on what we are seeing relative to us.
Yeah. So we see a magnetic field because it's moving relative to us, but relative to itself, it's not moving at all. So there's no magnetic field to affect it. There was a theorist who did come up with an idea that an electron could actually be affected by the magnetic field it creates, but you know, like most physics theories, I hear about them and then never hear about them again. Some of it will come out in the wash, they'll be hailed as geniuses, not really realizing that 99% of what they come up with is complete garbage. So it will not be affected. Also, if it does affect itself, we've sort of violated Newton's third law.
Also, the magnetic field lines, or the particles which transmit the magnetic field lines, travel at the speed of light. And so in order for the electron to be affected by it, it would have to go faster than the magnetic field lines.
All right, so this force that the magnetic field creates, well, it depends upon what the charge is. It depends upon how fast the charge is moving, and it depends upon the magnetic field itself. Notice that there's the cross product in there. So when you're multiplying, doing a cross product, what does the answer tell us? Or what can you tell me about the answer of a cross product?
Flash back to torque.